Have you ever wondered how a basketball swishes through the net or why the moon orbits the Earth? The answer lies in the fascinating world of mathematics. In this project, we'll explore the power of mathematics in understanding our world. We'll dive into the physics behind a basketball shot, the force of gravity that keeps us grounded, and the principle of motion that govern everything from a falling apple. Join us as we uncover the elegance and utility of mathematics in our daily lives.
Mathematics is not just a theoretical subject, it's a powerful tool for understanding the real world. In physics, for instance, mathematical equations help us model and analyze the motion of objects. Let's explore a real-world example.
A sample problem relating to applied mathematics in the context of kinematics is this. Sartre's body was at rest, but he suddenly bolted and accelerated because he realized he was late.
Run. Run.
When he ran, his body traveled for 5 minutes. The constant acceleration provided to the body was 2m/sec2. To find the final velocity the object had before coming to a stop and answer the equation of motion used to find the final velocity, we use the formula of first equation of motion, which is v equals u plus at, where v is the final velocity, u is the initial velocity, which is 0 meters per second because Sartre started from rest, is the acceleration, 2 meters per square second, t is the time of travel, 5 minutes, which needs to be converted into seconds. First step. Convert time from minutes to seconds, t equals 5 minutes. T is equal to 5 times 60. T equals 300 seconds. Second step. Substitute values into the equation, v equals 0 plus 2m divided by s squared times 300s. v equals 600 meters per second. So, the final velocity before Sartre comes to a stop is 600 meters per second. This problem demonstrates the intersection of applied mathematics and physics. The mathematical tools allow us to quantify the motion, while physics provides the underlying principles that govern that motion.
Beyond the thrill of the game, basketball is a fascinating blend of science and sport. The physics of projectile motion and the mathematics of probability underpin every successful shot. By understanding these principles, players and coaches can optimize their performance and elevate their game.
Here in Metro Dumaguete College, we're not just focused academically, but our school takes pride also in extracurricular activities such as sports. Did you know that mathematics and physics plays a significant role in the fields of basketball? Acceleration is directly proportional to the net force and inversely proportional to the mass. In order to shoot this ball accurately in the ring, we need to use the equation, which is force equals mass times acceleration. Now try it. Okay, do this. Force equals to mass times acceleration. So basically, when you apply those equations, you can accurately shoot this ball to the ring.
Shooting a basketball involves both physics and mathematics in several ways. P-trajectory prediction. Combining physics and math, you can calculate the trajectory of the basketball to predict whether it will go through the hoop, given the initial conditions, velocity, angle, height, etc. A player may adjust their shot based on these calculations or their experience with the ideal shot parameters. Optimization of performance. Using mathematical models of projectile motion, players can optimize their technique to improve their chances of scoring. Coaches use physics and math to design drills and strategies based on these principles, increasing the player's skill in shooting hoops. Together, these fields allow us to understand and improve the process of shooting a basketball, from basic principles of motion to advanced techniques used by professional athletes.
One of the most iconic moments in the history of science involves a falling apple and a curious mind. Sir Isaac Newton's observation led to a groundbreaking theory that would reshape our understanding of the universe. Let's explore a real-world example.
Gravity is one of the most famous scientific stories of all time. While the exact details are debated, the core idea is that Newton was inspired by observing a falling apple. Here's a breakdown of the story. The apple incident. Observation. Newton noticed an apple falling from a tree. Question. He wondered why the apple fell straight down, rather than sideways or upward. Insight. He realized that the same force pulling the apple down must also be responsible for keeping the moon in orbit around the Earth. The theory of universal gravitation. Formulation. Newton developed the theory of universal gravitation, which states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Mathematical expression. This theory is famously expressed in the equation F equals g m1 m2 r squared, where F is the force of gravity between the two objects, g is the gravitational constant, m1 and m2 are the masses of the two objects, r is the distance between the centers of the two objects. Legacy revolutionized physics. Newton's theory of gravity revolutionized our understanding of the universe, explaining the motion of celestial bodies and the behavior of objects on Earth, foundation for modern science. It laid the foundation for classical mechanics and inspired further scientific discoveries. While the exact circumstances of the apple incident may be debated, it remains a powerful symbol of scientific inquiry and the importance of questioning the world around us.
That would be all. Thank you so much for watching.